What is up, AP Physicsers? We are going to be talking about the beginning of a new unit today, and obviously, you guys are at home now. So, we're going to be talking about work and then a little bit of energy today. So, a couple of definitions. So, work is basically force applied over a distance. And I should say a parallel force applied. All right. So, for example, our equation that we're going to be dealing with here on a simple case is force times distance. So, F is force, D is distance. And we have a little extra piece added in here as well. That is cosine of theta. So, the idea here is, let's say you have a box being pulled at some angle above the horizontal, which is theta, which is F. That you're pulling this over some distance D. Well, this x component of the force, which is in the same direction of the motion, is that F times cosine theta because it's the adjacent side. So we have our equation of Ft cosine theta for work. So that's our first equation that we're going to be dealing with today. So there are a couple different things that can happen with work. You can indeed have negative work. So positive work means that we have the force in the same direction as the motion. So if you're pushing it to the right, it's moving it to the right, and so on and so forth. Negative work would be an example where the force is in the opposite direction. So like friction, if you're moving something to the right, friction acts to the left. So friction can indeed do negative work. And you could have something where there is zero work. So things here might be no movement could cause this to happen, or perpendicular force. So, for example, if you're pushing a box along the ground itself is not doing any force. It has an upward force via the normal force, but the normal force is not making the box move. So you can have zero work done as well. So this will help you solve numbers 1, 2, and 3, I believe, on the homework. And moving a little bit further, a lot of you have heard of energy before and what it entails. But the idea here is we have two different kinds. You have kinetic energy and we have potential energy. So kinetic is based on movement. So this is energy, energy based on movement. And it has an equation of Ke equals 1/2 m times v squared. And we also have potential energy. I'll usually refer to it as PE or potential energy, but technically it is gravitational potential energy because gravity is what's giving us this energy here. So gravitational potential energy. We'll talk about elastic potential and chemical potential and things like that. But for now, it is just gravity. So this is energy based on a height. And really it's a height above the ground or above a 0 point or a reference point, but most of the time it's how far is it above the ground. But I will put in here or reference point. All right. So those are the two kinds of energies we have. So the equation for gravitational potential energy is just a mass times gravity times height. All right, now something interesting here. Let's say you're lifting a box. Well, mg could be concerned as the force, and the height could be concerned as a distance, right? So we'll get into how work and energy are kind of the same idea, but there is something called the work-energy theorem. So basically, work and energy are in the same units. So this is something we'll talk about a little bit later, but that's kind of a neat little caveat that we'll talk about. So units we're talking about here. Units, we have something new. So if we take work equals force times a distance, force is in newtons, distance is in meters. So newtons times meters is that is a unit for sure, but this creates something called a joule. So it's capital J is the way we denote that, but it's called joules. So this is our unit for energy and work, actually. So this is, like I said, that's for both of them there. Okay. So we talked about work, we talked about different types of energy. The last thing to talk about for today is the conservation of energy. So the idea here is energy cannot be created nor destroyed. But it can change forms. So the idea here is if you throw a ball vertically in the air at a certain speed, then it will go to a height based on that speed. Whatever energy you started out with is how much energy you will have at the end. So some examples or example formulas that we might use. I'll give you a generic one. So, for example, you throw a ball in the air, vertically so throw a ball up. You would start out with 1/2 mv squared. It will turn into mgh. Obviously, the m's will cancel here, and you can solve whatever you're given. You might be given a v, or you might be given h, or depending on what the situation is. But there's one setup. Now, the same exact setup, really, it's just reversed. But let's say you're dropping a ball. So drop a ball from a height. Here you start out with mgh, and it turns into kinetic energy as it hits the ground. Again, m's will cancel. You might be given h or solving for v. So as you can see, the way you solve them is very, very similar. But the algebra after this that follows is usually pretty simple. On both of these, would be using g equals 9.8. You don't have to plug it in as a negative. You can plug it in as a positive. But that is your generic conservation of energy explanation, if you will. So some extra explanation here that might help some of you is energy can't be created or destroyed, but like for example, if you run and slide on the ground and you come to a stop, so obviously you had energy because you're moving, but then all of a sudden now you're stopping. So the idea there is some of the energy I'll call it's lost to heat. Like it creates heat or it creates noise. And those are things called non-conservative forces. We'll talk a little bit more about that later on. But basically, if you lose energy to heat, you can't really get it back. Because it heats up the surroundings around you, you can't really harness that heat again. So that's kind of the idea of conservation of energy is it is conserved, but sometimes it goes into doing something else. So like friction robs energy a lot of the time. So hopefully this will get you guys set up to solve most of your